Okay, this is SpotOn Maths, the question on the activity on Pythagoras, question number 2. So you may have noticed that when I gave you your piece of paper for your maths helper book, I discussed the theorem of Pythagoras with you, but on the bottom there was a little piece, this little piece over here. It said to you there are some special triangles called Pythagorean triples which have all the sides as whole numbers. So what happens sometimes in maths, in geometry questions and stuff, they like you to realize that there are certain triangles called Pythagorean triples, and in these triangles all the sides have a whole number or an integer, okay, and in the question they refer to them as an integer. So if you've been doing your Pythagoras homework, you notice quite often the hypotenuse is a really strange number. The number's like a really different length. And so as a result of that, there are certain special triangles and multiples of these triangles that are called Pythagorean triples. So this first triangle that's drawn here is a 3, 4, 5 triangle. If I double all the sides, I can get a 6, 8, goodness me. Let's try and draw that straight up. I can draw a 6, 8, 10 triangle, okay, and it's a multiple of a 3, 4, 5 triangle. It's like a similar triangle, and these triangles always have whole numbers for the sides, and so then sometimes maths teachers like to put them in tests, so you should know they exist. But with any right angle triangle you can always use the Pythagorean theorem to work out is it a right angle triangle or not. So in this question 2, it says to you a Pythagorean triple consists of 3 integers a, b and c such that a squared plus b squared equals c squared. So it says an example of a Pythagorean triple is 3, 4, 5. So you can see this triangle I've drawn here, the sides are labeled as 3, 4, 5. And if you get out your ruler and you draw a line 3 centimeters long and another line 4 centimeters long, and they're at right angles to each other, and you join them, you'll form a triangle and you'll find the hypotenuse is 5 centimeters. Okay, so they're just interesting triangles that are like interesting to look at. So now this question is just like the 50-50 number 11 to 20 question. It gives you 3 numbers and you must draw the fake triangle. So like number A would be 6, 8, 10, where you can see I drew this beautifully with the ruler, not. Okay, the second one would be 2, 4, and this would be 6. Okay, if these are indeed right angle triangles, okay, and then this one would be 7, 12, and 15. Okay, so what you have to do is check, are they telling the truth? Is this true? State whether the following are Pythagorean triples or not. So the first thing that would make them a Pythagorean triple is that all of the numbers are whole numbers, especially the hypotenuse. So what you have to do is you have to check exactly the same way you do on the 50-50. Pythagoras says a squared plus b squared equals c squared. So for number A, we would say 6 squared plus 8 squared equals c squared. So 6 squared is 36, 8 squared is 64. Okay, 36 plus 64 is 100, so 100 is c squared. So c must be equal to the square root of 100. Remember inverse operations. So c equals 10. And that is what they told you in the question. So 6, 8, and 10 are all whole numbers. And yes, they agree with Pythagoras' theorem. So then yes, this is a Pythagorean triple. If we now look at number B, let's try number B. Number B says a squared plus b squared equals c squared if it is indeed a Pythagorean triple. So we know that they gave us 6 as the longest side. So we can say a is 2, b is 4. So 2 squared plus 4 squared equals c squared. So 2 squared is 4, 4 squared is 16 equals c squared. So 20 equals c squared. So c equals the square root of 20. Now if you go to your calculator and you put in what is the square root of 20, it's going to tell you 2 root 5, which is the answer in surd form. And if you put it in decimal form, it's 4,47 if I round to 2 decimal places. Now, what did the question tell you C was? They told you C was 6. So is 4,47, goodness, what a shaky line. Let's write this 4,47 nicely. 4,47 equals C. Is 4,47 down here that we calculated equal to the 6 that they told us? No, it's not. So this is not a Pythagorean triple. Okay, or you can say just no. And then you go to the next one, 7, 12, 15. Okay, and I don't see it in my list of common Pythagorean triples here, so I'm guessing that it's not. Okay, but you just check a squared plus b squared equals c squared. So 7 squared plus 12 squared equals c squared. So this is 49 plus 144 equals c squared. I don't know what that is. Luckily, I've got my calculator handy. So then c squared equals 193. So if we square root 193, we get the square root of 193. And the moment your calculator gives you this answer under the surd sign, you know that this is not a whole number. So the answer to number C is once again going to be no. Those 3 whole numbers, yes, you can draw a triangle with them, but no, it will not be a right-angled triangle. They have to be all whole numbers to be a Pythagorean triple, and they have to follow Pythagoras' theorem, and so B and C don't, but A did. And if you really want for bonus points, you can go and learn these Pythagorean triples. Usually the 3, 4, 5 and the 5, 12, 13 are most used by teachers in tests, and then sometimes you can just know the answer before you do any calculations.